Mohammed Fafana, and I'm going to talk about how the nuclear power plant works. This is the three main parts of a nuclear power plant. This is the basics, and this is all you need to have a nuclear power plant. And this is the containment structure. This is the turbine building, and this is the cooling tower.
Why is the cooling tower like essential in a nuclear power plant?
Basically, all it uses is that it brings hot water into it, and it has cool water.
Yeah.
So the hot water collides with the cool water, and that's when steam happens. That's why I usually see that. That's like probably the trademark of a power plant, that little steam. All that is steam, hot water.
Wow. Yeah. I never knew that. Because when I'm in Jersey and I'm driving by, I always see these factories and like I always see the smoke. I always think it's hazardous, but I mean, since it's coming from water, it shouldn't be.
Yeah, it shouldn't be. But usually it's just steam. Sometimes it can be carbon dioxide, all the other chemicals.
Okay, definitely.
Yeah, I got you, man. All right, now I'm gonna talk about the containment structure, which is this right here. This is where the big enchilada is. This is where everything happens.
Enchilada. I like that word.
Yeah, that's my favorite food, man. And the general type of nuclear reactor is the pressurized water reactor. Basically, all they use is this water from a nuclear reactor, and that water heats up some type of metal. Then they run like water through that metal. After that, they form steam. When steam happens, steam like collides with the turbines, and it turns it. Once the turbines are turned, it creates energy. All right.
Yep.
Then I'm gonna tell you what kind of nuclear reactor is it, and the pressure vessel is usually like 12 meters tall, and I'm gonna illustrate what it looks like, All right, this is the building right here, right? This is big right here, right? And the reactor vessel is like 12 meters tall. That's like, takes up like probably the whole thing, This is the reactor vessel. And each reactor vessel is like maybe hundreds or thousands of like fuel rods. There we go. This is like a fuel rod, right? My job's not the best, but this is a fuel rod. It's usually around 5 meters long, so it's usually 5 meters long. It's roughly like this tall of fuel rods, Then each fuel rod, we have fuel pellets. And in each fuel pellet is uranium-235. And uranium-235, you got a question?
I just want to know what exactly is made in these plants. Like what is produced here? A nuclear power plant.
Oh, all right. I'm gonna get to that part real quick. All right, but like I'm gonna explain it, man.
I'm very excited.
All right, with these it's uranium-235, and for you non-science majors, this is uranium-235. Where is it? Number 92 has a U, and this element is radioactive and kind of unstable, All right, and 235 is the isotope, and that just tells it's a different type of uranium, All right, and with the use of uranium, it creates a large amount of energy and radiation. All right, so keep that in mind. So with that, water runs through the vessel, and like once they start the reactor, they put water through it, and it's superheated, but it's not boiling, You want to know why? Because like it's at 560 degrees Fahrenheit. You want to know why?
Wow.
Because they have a water pressurizer where they like keep it like constant pressure, so it won't like reach boiling, but it'll still be like super hot. You understand what I mean? Gotcha. All right. Next slide. All right. Then this is where they have once they like make the water go to like 560 degrees Fahrenheit, it goes through a heat exchanger or a steam generator. All right, keep that in mind. This is a steam generator. Okay? So with that, they make water run through like a pipe or metal tubes, where it's generally like maybe 2 meters long. So it's basically like U tubes where it's metal and the 560 degree water runs through it, making it super hot. But keep in mind, the water is radioactive because it's touching uranium, and uranium is radioactive. So with that, the water like makes contact with the metal tubes, and with that, it steams up and it creates steam, and that's why it's called a steam generator, because it creates steam. So with that, once steam is created, the water passed through the steam generator will produce steam, and we pipe to the turbine unit. This is the turbine unit right here. So what I was saying, this is the reactor right here, and this is the uranium, this is the fuel rods, you know, and this is where the water goes through. And once the water goes through here, you know, it's like superheated to 500 degrees Fahrenheit. You know? That's what I told you. And when it goes here, this is the metal tubes right here. See, it's a U. They usually call it a U tube. You know, so this water is separate from this type of water. You know, by the change of colors. You know, so where they get that water from is from like a river or a cooling tower. You know, that's that big cylinder. You know, with that, it goes through this steam generator. You know, then when the steam goes through, it goes to the turbine right here. It's a turbine. All the nuclear power plant is that it just turns a big turbine and makes energy. That's what you really need to. That's what a nuclear power plant is. They use like radiation. And, it's a reactor. You know, reactor makes heat. Then you use water. And with water, they make steam. With steam, they turn a turbine. With a turbine, they get energy. That's what a nuclear power plant really is. All right. And I'm going to describe to you the turbine unit. All right. So basically, steam enters through the pipeline, you know. Then it goes through a high pressure turbine, which is where they get most energy, and like usually around two low pressure turbines where they get like some extra type of energy, you know, with the extra steam left over that in turn the high power turbine, you know. With all that, it spins, and they use a spinning generator. That's how they create. That's how they get the energy. And with that, they create AC electricity. And usually, there are two types of electricity. There's DC power and AC power. In America, we use AC power, you know. But the rest of the world, we use DC power. I don't know why, but with that, they have to make 60 hertz of energy, no matter what in America. No matter what, like even like, you know, what was it? You know, windmills?
Yes.
Yeah, like during a hurricane, right? You think it'd be good to use a windmill, right? Huh?
Yeah.
Huh?
Yeah,
That makes
yeah,
sense.
yeah, you would think
What
so.
about windy day, you know? Right? Wouldn't it make sense to use a windmill, right?
Yeah, it would.
No, not really. no. You know why? Because like,
Why?
it had to turn a specific speed to create 60 hertz energy. If it's more than 60 hertz, you can't use it. It's a waste. You know, if it's less than 60, you can't use it. It's a waste. So it has to be exactly 60, and they have like control regulations where if it goes too fast, right, they have to like shut it off. That's why like during a storm or a thunderstorm, it's always off. You know, people think like that's a waste of. Why don't you like turn it on? You know, but no, it has to make 60 hertz energy, and that's what a power plant uses too, 60 hertz, no matter what. And that's all you use. And with that 60 hertz energy, they send all that energy to a grid. I'm gonna explain this to you later as well. All right, in the turbine building, after the steam turns to turbines, it goes to a condenser, and basically once it condenses, it's still sort of a little bit heated. So with the condenser, it turns the steam to liquid, and the cooling tower collides with the steam that became cool, and it goes back to the same steam generator, which is in the containment building where the nuclear reactor is. All right, and the water is usually originated from a river or a cooling tower. You know, and a cooling tower is basically where it's like hot water is sent to be cooled. Basically, they have hot water showers, and like in the bottom it's like thousands of liters of water, you know, and it showers hot water to the cooling tower. Then once that happens, the water becomes cool, but then steam goes up. With that, you think it's a lot of steam, but basically around 2% of water is expelled from the cooling tower. And this is what a cooling tower looks like usually, you know. And that's water vapor. That's not any bad thing. It's just water vapors, you know. And it just goes to the sky, you know. And this is generally what a nuclear power plant looks like. All right. And I'm trying to describe to you what the electricity is used. I told you you need to use 60 hertz of AC electricity. Then it's sent to a grid where it's prioritized and like organized, you know. with that, it's into an electrical bit of like, let's say, it's a little complicated. I won't go into that. All you need to know is it goes to electricity building, and where it's like transferred to like telephone lines, you know, those big telephone lines, and like those are like super like electricity like filled, you know. So it's like you don't want to touch that, you know. With that, that's where you go to a transformer, you know. I'm not talking about like the transformers, you know, with the, like, you know, the robots, you know what I mean? Like, so like, you know, a transformer is like, it's usually like, how do I describe it? I'm gonna draw it to you. It's like these are telephone lines right here, you know. Man, I should be an artist, you know. And usually, like the transformer is like this big, flat thing right here, you know. This is a transformer, and basically, all it uses is that, like a large amount of energy is transferred to the power lines, you know. With that, the transformer like reduces that energy, you know, and kind of organizes it, you know. With that, it could like be transferred to your home or, you know, anything else. But that is only possible if you pay for your electricity bill. You know? I'm just saying. All right, what else? Let's see. The water used. All right. Yeah, the water used from each circulation building, like each building is kept separately. As I told you before, where the reactor is, the water used for that is radioactive. So like they have to keep on using it, and like if they have to dispose it, they dispose it in a particular manner that no life will have contact with it, you know. And that's usually called a primary circulation system, you know. And the water used from the turbine tower is usually converted from steam to liquid, you know. And that's not radioactive, but that is used throughout both buildings, you know. Then the water from the cool tower is usually like water from a river that is used to go to the cool tower, and like from the turbine building, they just ran hot water through it to make it cool again, you know. And that's where the whole cycle began, you know? And if you're wondering, what's uranium-235, you know? Uranium-235 is the most important element used in a nuclear power plant or a nuclear bomb, you know? You ever heard of a nuclear bomb? Hiroshima, Nagasaki, you know?
Yeah, I heard of those.
You did?
Yeah.
Oh.
Those bombs are very dangerous, man.
Yeah, man. Like, they use large amounts, but with this element, you might think it's a lot, but nah. They probably use roughly the amount of, like, this table of uranium.